In this lesson, we will look at factoring trinomials when a equals 1 and trinomials when a is greater than 1. A trinomial is an expression with three terms. The standard form of a trinomial is ax squared plus bx plus c. In this video, we will look at when to factor the trinomial when a is equal to 1. When factoring the expression x squared plus 8x plus 7, the first thing we want to look at is what can multiply together to equal 7. The easiest way to do that is to create a tree where we get the factors of 7. The only factors of 7 are 1 and 7. Next, we want to look at, of those factors, how can we add them to equal a positive 8? The only way to add those two to be a positive 8 is a plus 7 and a plus 1. So our factors are then x plus 7 and x plus 1. In this next example, we're going to look at x squared plus 11x plus 18. The first thing we want to do is list the factors of 18. The factors of 18 are 1 and 18, 2 and 9, and 3 and 6. Of those factors, we want to find the two that multiply together to equal 18 that we can also add together to equal 11. The two numbers that add together equal 11 are positive 2 and positive 9. So our factors will then be x plus 2 and x plus 9. In this problem, x squared plus 2x minus 24, we have to look at what can multiply together that's going to equal negative 24. We'll start by writing out all the positive factors. Along the lines of being able to multiply to equal negative 24, they also have to be able to add to be positive 2. So when I look at the factors 124, 2 and 12, 3 and 8, 4 and 6, the only way to get a negative 24 and a positive 2 is to take a positive 6 and a negative 4. Therefore, my factors are x plus 6 and x minus 4. For your benefit, take the time to pause the video and write down these trinomials. In the black, it will give you the standard form of trinomial with different signs. In the red will tell you how you need to factor it with the signs. In the top left corner, ax squared plus bx plus c, when you factor it, if you have two positives in the trinomial, you should have two positives in your factors. To the right of that, ax squared minus bx plus c, you should have two negatives in your factors. In the bottom left-hand corner, ax squared plus bx minus c, if the positive is before bx, then the biggest number needs to be positive and your small number needs to be negative. To the right of that is the opposite. With two negatives, your biggest number needs to be negative and your smallest number needs to be positive. Please try these four examples on your own. Don't forget that you need to factor out any greatest common factors first. Now let's look at what if a is greater than 1. First, we always need to see if we can factor out a GCF. If there's no GCF to factor out, next we'll use what we're going to call the a times c method. In this problem, we have a GCF of 2. So we'll factor a 2 out and we'll rewrite the expression. When I factor a 2 out of everything, it gives me 2 on the outside, x squared plus x minus 2. Now we will do our factoring as if a is equal to 1. So I'm going to look at negative 2 and write down the factors. The factors of 2 are 2 and 1, but I need them to be a positive 1. The only way for two numbers to multiply to be negative 2 and add to positive 1 will be plus 2 and minus 1. Make sure that you always include the GCF out front. Try this problem on your own. In this example, there is no greatest common factor, so we can't factor anything out. But what we can do is what we're going to call the AC method, where I'm going to take A and I'm going to multiply it into C. By doing that, I get a new expression of x squared minus 2x minus 15. The 3 goes over to the negative 5, I multiply them together, and I rewrite the expression. Now I have a trinomial where a is equal to 1, so I can factor like normal. So I want to find out what can be multiplied to equal negative 15 that can also be added together to equal negative 2. When I write the factors of 15, I see that 1 and 15 and 3 and 5 are my factors, so I need to use 3 and 5 because I can manipulate those to give me negative 2. When I do that, to factor the problem a times c, I will get x minus 5 and x plus 3. But that's the factor of the new one when I multiplied it. I have to get the factors of the original. So in the purple where I have circled 3, we have to take 3 back out. So we will divide each number by 3. If you notice, x minus 5 divided by 3 will not divide evenly. If it does not divide evenly, then all you do is move the denominator out front. So instead of it being x minus 5 over 3, we'll move the 3 out front to 3x minus 5. In the second one, 3 divides into 3 evenly. So we have x plus 1. You cannot forget to divide the a term out every time, and you have to divide it into both of them. And there's our final answer. Let's look at another example. We have 2x squared plus 3x minus 9. Start the same way. We're going to multiply 2 into negative 9 and rewrite the expression. When I do that, my c term becomes negative 18. So just like in normal factoring, we'll see the factors of 18, we will list those out, and then we will decide which of those 3 can we get a positive 3. When I do that, I'm going to get x plus 6 and x minus 3. Now that's the factors of the second one after I multiply. So what I have to do is go back and take 2 and divide each one of those by 2. 6 divided by 2 is 3. Since 2 does not go into 3 evenly, we will move the 2 in front of the x, and I will get my final answer. Let's look at one last example here. No greatest common factor, so I'm going to take 5, multiply it into 9, and rewrite it. That leaves me with 5x squared minus 18 plus 45. So I have to find two numbers that multiply to be a positive 45 that will add to be a negative 18. So I will write the factors out of 45. The only two that will be positive 45 and negative 18 would be a minus 15 and a minus 3. Go back to your original equation, take a, which is 5, divide both of them by 5. Since 15 goes evenly, I'll rewrite it as x minus 3. In the second one, since 5 does not go into 3, I will just move it in front of x. This is the same process that needs to be done for every problem where a is greater than 1, and you cannot factor it. Try these problems on your own.